Ali, good morning everyone. Aloha o Bryce ko inoa no koror Palau Maiau. My name is Bryce Bonicacio. I come from the beautiful islands of Palau. And yeah, I conducted my experiment in Kawainui Marine Laboratory with the help of my mentor, Dr. Robert Richmond, and the grad students Lexi, Alex, and Keiko. So, as we all know, Pacific Islands rely on their ocean, like reefs, as a source of food, jewelries, and scientific researches. But these come with threats, threats to the reef, such as pollution, global warming, and sedimentation. For my project, I wanted to conduct an experiment on the effects of sediments against the fertilization of corals and sea urchin gametes. So, let's talk a little bit more about what sedimentation is. So, sedimentation increases by constructions, land intensities, and erosion, like natural disasters. They are suspended materials that run off in a watershed down, eventually ending up in the ocean. And these are a big threat to marine organisms. And it is known that lo'is are good sediment filters. So my question is, how do sediments affect the fertilization of coral and sea urchin gametes? So I hypothesize that the sediments do cover the corals and algae, preventing further development. And my predictions are that sediments will have a negative impact on the fertilization of coral and sea urchin gametes. And that Kawainui lo'i, which is this site, number one, will reduce most fertilization success because of its fine sediments. So the first species I did my project on was the Montipora capitata, which is the rice coral. It's a main Hawaii reef building coral species. Hawaiian name Koa, Palawan name Marand. It is a hermaphroditic species, which means it has both male and female organs. It is a mutualistic, yes, it needs a mutualistic interaction with the zooxanthellae to survive, and it's what it gives its beautiful color. It's important for our culture because it provides us food that we eat every day and more cultural. So what I did was I started from collecting samples from the Kailua watershed here in Kawainui, Lo'i, then in Hamakua Marsh, then the Kailua Beach Park in watershed down to the ocean. So first up, we did coral spawning, where we trapped the eggs. We then brought them back. We pipetted them into jars from egg bundles though. Egg bundles have both coral and sperm in them, but we have to pipette one from different colonies in order to have fertilization, because from the same colonies would have polyspermy, creating no fertilization. We then wait for a few hours, and then we determine fertilization, the development by using a microscope to watch the fertilized and unfertilized eggs and count them off. There's some real life action of my experiment. That's how the trap looks like. And then the eggs, sperm. As you can see, that the ones with cleavages are the ones that are fertilized, and the circular ones are the unfertilized eggs. So what I saw from this. So this is the graph for my average percent of fertilization for the Montipora capitata rice coral. X-axis being the treatments and Y-axis being the percent of fertilization. And we can see that 35% of everything was fertilized, and all the sites did not have any fertilization, meaning sediments have a big impact on the fertilization of the coral, Montipora capitata. So then I wanted to do more, find out more about different species in the ocean. So I looked up, I did another experiment on the Trinustes cratilla, which is the collector sea urchin. Hawaiian name Hawa e Maoli, Palawan name Ibul. It is a gonochoristic, meaning it has either male or female organs. Is a vital and important algae consumer for every reef around the Pacific Islands. It eats the algae off the reef from consuming or from covering other marine organisms and eventually killing the organisms. I did almost the same thing with this experiment, but for this I used a 0.5 molar potassium chloride to inject into the sea urchin to activate its hormones and to let it disperse out. I basically forced to, yeah. And we wouldn't know if it's a female or male unless we just watch what comes out of it. Yeah. And I did the same thing. We waited for we pipetted each of them into like a jar, and then we waited a few hours to see fertilization and observe fertilized and unfertilized eggs. There's some real life action with my grad student Lexi. She helped me with all my projects. Those are eggs down there looking orange, and then this is sperm. This is how sperm looks like over here. So as you can see in that, the first picture, the one with cleavages inside shows fertilization. It means it's fertilized. It's a fertilized egg and the envelope around it. The TV static looking one, like clear, means it's an unfertilized egg. And this is how it looks like, covered by fine sediments and only fine sediments. So I calculated the average percent of fertilization for the Trinustis scrotilla sea urchin, collector sea urchin, x-axis being the treatments and percent of y-axis being the percent of fertilization. And I saw that there was 100% fertilization in all my replicates, which I had 6 replicates for each jar. And as you can see from going down the watershed, starting from site 1 to site 3, we can see that the fertilization gets higher. And I think it's because as we go down the watershed, the fine sediments are trapped by the Kawainui and Hamakua marsh, leaving Buses Beach for more like bigger or like coarse grained sediments, making it like easier for fertilization success. Yeah. So what I know now is that Lo'i does trap a lot of sediments, specifically fine sediments, and research has been done that it does trap 90% sediments from going down the watershed. It is a well-known food source. What are we about to eat today? It creates recreational jobs and activities like what we took part in. And it is a traditional practice. Shout out to Kaulu Kalana. They are bringing back traditions and practices that we need to keep in, yeah, order to. So what we know now is that sediments do have a great negative impact against the fertilization of the both species. And that taro patches do help with sediment stress. And from the sea urchin graph, we can see that success was higher at site 3 compared to the others because of the coarse grains. And we know that research could help potentially encourage more restorations, like what we do here. What I want to figure out is to try it out with other coastal marine organisms, like not specifically sea urchins or corals, like other coastal marine organisms. I want to try it at the different sediment concentration experiment. Oh, and for my project, I did it at a 25 milligram sediment concentration experiment. I want to repeat it in other places with watershed restorations. And most importantly, I want to take this back home and replicate a project I can do to help my island. To acknowledge everybody, I want to thank everybody for sharing the knowledge with me. It was really fun and cool. This is going to get sad, so I don't want to continue on. And thank you. Questions?